Alright, so 6.4 deals with functions, which is also something relatively new to you, something that you may not have encountered much in your math career. But if you are the person who is planning on taking the pre-calculus and eventually calculus route, knowing what a function is very important. Okay? Everything that you've learned up to this point still matters and still will be used. So functions are still relations. So all the knowledge that you gained working with relations is still applicable. You'll be able to, or you'll be asked to find the domain and range of functions, and you guys should be relatively fluent in that by now. But I have to be careful in describing what functions are specifically because they are not like all other relations. If you imagine this circle as the set of all possible relations in mathematics, which is a very, very large group of things, functions would be a smaller subset of that group. Proportionally, maybe it's not that small or that large, but I draw that diagram just to let you know that there are a lot of relations that are not functions, but all functions are considered relations. Okay, so it's kind of like a special class of relations, kind of like you are not all of PCS. You are a small group, small special group of PCS. Okay, so think of yourselves that way, or think of functions that way. Okay, so the key characteristic that differentiates functions from all other relations is this notion or this idea of a one-to-one correspondence between the domain and the range, which probably sounds really fancy and hard to understand. But I'm going to show you a bunch of different examples, or illustrations I should say, of what a one-to-one correspondence means. Sometimes it's also called a bijection, but that's getting a little too far. Okay, a one-to-one correspondence. This is a defining feature that makes it unique from all other relations. And I'm going to show you basically what that means. Okay, so maybe another way of saying one-to-one correspondence is when I have an equation, or when I have a relation with an independent variable and a dependent variable, a one-to-one correspondence is when I put in a value for my independent variable, and out pops one and only one dependent value for the dependent variable. Okay, so I put a number in for the independent variable, and out pops one and only one value for the dependent variable. Okay, I'll show you what that looks like in a bunch of different situations here. Okay, so I have this this comparison for two types of relations. Both are relations. They're just ordered pairs on a graph, because it's a little bit easier to understand this using ordered pairs. And their corresponding table of values underneath. Okay? One of these is a function, and one of these is just a plain old relation. I'm going to tell you how they are different. Okay? Or maybe I'll just ask you, what is different about these two relations? Do you notice any key differences? Other than they're just different shapes and the dots are in different places. Because that is obvious.
Straight line.
Straight line, okay, maybe. That's not the difference, but...
The ones on the left are all negative on the x-axis.
Okay, sure. What else? Okay. So, if I had some kind of equation that allowed me to input a value for x and output a value for y, notice what would happen in the left-hand relation here. Whenever I input -4, I generate this value 4. That would be this point up here, E. If I input -3, I get the output 3. That would be this point up here. Input -2 for x, out pops 2 for y. That would be this point, and so on. But notice, when I get down to this portion of the relation, I input -1 for x, What happened last time when I input -1 for x?
You've gotten a positive
I got a positive 1, but this time I'm getting
a negative.
-1. So this value for x, -1, is tied to two output values. It's tied to +1 for y for the output and -1 for y. You understand what I'm saying? Okay. Likewise, -2 is tied to two output values for y. You can spit out -2 or +2. Okay, and you see that in these 2 points here. Right? When I input -2 for x, I either get 2 or -2. And same thing for -3 and -4. Two values associated with it. And because of that, this is not a one-to-one correspondence. It would be a one-to-one correspondence if every time I input -1 for x, I always got 1 for y. But that is not the case here, because sometimes I can get -1 to pop out. And the circumstances that would govern whether we get 1 or -1 we'll study further on. But the point is, the input -1 is tied to two outputs. It can only be a function if it's tied to one output every single time it's put into the function or into the relation, not the function. Okay? So this is a relation. Okay? Because it's not a one-to-one correspondence. Let's take a look at this other graph and decide whether or not it's a function or a relation. Okay? So let's look at the inputs of x and the corresponding outputs. So I put in -3 for x. What do I get for the output?
Negative. No.
-3 for y, right? That's this point here. Do I get anything else but -3? No, right? If I trace or look at all the -3 values for x, the only point that corresponds to -3 for x is -3 for y. Same thing with -2 for x. Out pops -2 for y. 0 for x, I get 0 for y. Put in -1 for x, and I get 1 for y. -2 for x, I get 1 for y. 3 for x. Oh, these should be positives. Whoops. That should be positive and positive. Otherwise, I would mess my whole example up. Put in +1 for x and get +1 for y. +2 for x. +1 for y, and so on. So this +1 is tied to 1 and no other number.
Our seat says they're negative, so do we just change that?
Yes, yeah, change these to positive. This 2 is tied to 1, and that's it, not any other value, and 3 is tied to 1. Okay? It is possible for dependent variables to have multiple inputs that it's associated with, much like we have here. 1 in the dependent variables, or in the range, is tied to 3 values in the domain, but it can't go the other way around. Okay? If I input +1 for x, I should always get 1 for y, and never anything else. Okay? So this is a function.